we will end our energy resources today. So it is the part 3 of energy resources. I have already posted the part 1 and part 2 in the YouTube. So what is energy resources we all know. So today we will start with the tidal and wave power. So tidal and wave power. So what is the tidal and wave power? So tidal power is a very easy thing. That is we all know the earth's surface, it is having 70% of water. So by warming this water, the sun, it can create the ocean currents and the wind that produces the waves. So it can be estimated that the solar energy it will absorb the tropical ocean in a week could equal to the entire oil reservoirs in the world. So 1 trillion barrels of oil can be reserved in this energy. So tidal power, it is nothing, it is tapped by placing a barrage across an estuary and forcing the tidal flow to pass through the turbines. So in one way system, the incoming tide is allowed to fill the basin through a sluice and the water is collected. It is used to produce electricity. So during the low tide, in a two-way system, power is generated and both the incoming and as well as the outgoing energy. So this is one kind of tidal power which is very much essential for the energy generation. So these kind of stations, they bring about major ecological changes in the sensitive ecosystem. In coastal regions, it can also destroy the habitats and nesting places of water birds, and it can interfere with the fisheries also. So this kind of tidal power is also having some disadvantages we can see. So a tidal power station at the mouth of a river blocks and the flow of polluted water into the sea. So thereby it can create some health and pollution hazards. Other drawbacks are also there. Some offshore energy devices posting the navigational hazard, and residual drift current could affect the spawning of some fish and whose larvae would be carried away from the spawning grounds. So they may also affect the migration patterns of several fishes that stays inside the ocean. So wave power, it is converted into the motion of waves into electrical or mechanical energy. For this kind of energy extraction devices that is used to drive the turbo generators. So electricity, it can be generated at sea and it can be transmitted by cable to land. The largest concentration of potential wave energy on earth is located between the 40 to 60 degrees of latitude. Another developing concepts, there harnesses the energy due to the differences temperature between the warm upper layer of the ocean and cold deep sea water. Next, we are having geothermal energy. That is also very much interesting. Geo means earth. We can see here in the slide, that is earth. Section of earths are there. So it can reach up to 5000 degrees centigrade at the center. So can you imagine how much degrees we are having inside our earth, in the center of earth? So this geothermal energy, that is starts with hot molten rock. These are called the magma. So deep inside the earth, which surfaces at some parts of the earth's crust. The heat rising from the magma warms the underground pools of water known as the geothermal reservoirs. So if there is opening, hot underground water will come over the land of the surface and it can form some hot springs also, or it may boil to form the geysers also. So with modern technology, wells are drilled deep below the surfaces of the earth to tap into the geothermal reservoirs. This is called the direct use of the geothermal energy. So in 20th century, this kind of energy, it has been harnessed on a large scale for spacing, heating, industrial use and electrical production, and especially in Iceland, Japan and New Zealand. So this kind of geothermal energy, it is nearly as cheap as the hydropower, and it is thus increasingly it can be utilized in future also. So however, the water from the geothermal reservoirs often contain minerals that are corrosive and polluting. So advantages are there also, but in disadvantage we may have some corrosive activity of the water, also we may have some pollution also. So geothermal fluids, that are a problem which must be treated before the disposal. Now we will be going in nuclear power. What is nuclear power? In 1938, so two German scientists was there, that is Otto Hahn and Fritz Strassmann. They demonstrated the nuclear fission. So what they found, it found that some nucleus, if it is splitted, split of the nucleus of uranium atom by bombarding with the neutrons, it may create some energy. So the nuclear power industry, however, it was born in late 1950s. The first large scale nuclear power plant in the world, it became the operational in 1957 in Pennsylvania, US. And also we also know that Dr. Homi Bhabha, he was the father of nuclear power development in India. Bhabha Atomic Research Center is there in Mumbai, where they all studies the development of modern nuclear technology. So India has 10 nuclear reactors at 5 nuclear power stations that produce 2% of the India's electricity. So these are located in Maharashtra, Rajasthan, Tamil Nadu, Uttar Pradesh and Gujarat. India also is having some uranium forms in mines in Bihar. There are deposits of thorium in Kerala and Tamil Nadu. So nuclear reactors use the uranium-235 to produce the electricity, and uranium-235 it can produce by burning 3000 tons of coals. 1 kg of uranium-235 is equal to the 3000 tons of coal. So just imagine the power of the nuclear energy. So the heat energy is produced in the reaction. It is used to heat water, and it can be produced as steam. It will drive the turbines to produce the electricity. The drawback is there that the rod that needs to be changed periodically. So this has some impacts on the environment due to the disposal of nuclear waste. So wherever it comes, the matter comes of disposal, we all know that they are having some polluting affected. We can be affected by some pollution for the nuclear waste system. So the disposal of the waste is becoming an increasingly serious issue. The cost of the nuclear power generation, it must include the high cost of disposal of its waste. So as the cost is high, nobody is disposing the nuclear waste properly. So it is having economical value, economical cost to dispose the nuclear waste. Otherwise we may have serious problems. Also, while if it is not also polluting the air, we also may have some single accidents, and it can kill thousands of people. So it make many of people seriously ill, and it may destroy an area for decades by its radioactivity. So which leads to death, cancer, genetic deformities and several things, which is very much accidental and which is very much warning for us. Land, water, vegetations, they can be destroyed for the long periods of time, because the activities of the nuclear thing will remain for a long period of time. The duration is very long. So that's why if one accident will happen, the duration will stay for a longer time, and it will affect the ecological balance as well. So these are the things which is very much related to the nuclear power plants. Next we will go for the energy conservation. So what is the conservation? Conservation means we need to conserve our environment. We need to conserve our mother, that is the mother nature. So conventional energy sources have the variety of impacts on the nature and the human society. India that needs to rapidly move into the policy to reduce the energy needs, because we all know that as the energy we are using, it is actually energy is destroying day by day. We are destroying the energy in several ways. We are not at all using. We are using some parts of the energy, and most of the energies are being destroyed. This kind of things should not be happened. So we are several things to thought about it. Now we are having some cooking. We can see in the slide that they are having some woods, that is the wood that is burnt for efficiently for some food. So this kind of things, cooking stoves or the chulas, that will help the movement of air so that the wood is burnt more efficiently. This can have the chimney to prevent the air pollution. So to prevent the pollution, we may have the chimney. That may affect. We all know that the smoke that is there for the, that is the smoke that is generated when the woods are burnt, that is very much polluting for us. So while over 2 lakh improved food chulas there has been introduced throughout the country, number of active use is unknown, and the most rural people is found to be unusable for several uses, because they are having some points that they will not use the things without their tradition. So in India 95% of rural people and 60% of urban poor still depend on the firewood. They will use the cattle dung and the crops residue for the cooking and other domestic purposes. So biomass also can be converted into the biogas, we all know. There will be 60% methane, 40% carbon dioxide generated by the fermentation process. So this is commonly used. Agri waste is dung of domestic animals and rice husk, coconut shells, straw or weeds. So this kind of reservation or conservation of energy is very much needed. We also know in hydro generation, where the hydropower generation. So we also know that the small hydropower generation units are needed to be formed, because they will not displace the people, they will not destroy the ecological balance, they will not destroy like forest or wildlife, anything. So the small hydrogeneration power is needed. And also some things are there, that is it is easy to waste the energy, but it is cheaper to save it than generate it. If we can save the energy, we can generate in a lesser way. So in that way we can save the energy. We can conserve the energy by preventing or reducing waste of energy and by using resources most efficiently. So people waste energy because the government subsidies. So if the real cost will be revealed, the people would not be able to afford the waste so carelessly. So we must be careful for the wastage of energy, as because it will give a serious effect in the near future. So if you can go, we are having some case studies that steel or the energy to produce 1 ton of steel, India spends the 9.5 million kilocalories, whereas in Italy it is 4.3 million kilocalories, and for Japan it is 4.1 million kilocalories. And for cement industry, over 2 million kilocalories are used to produce 1 ton of cement in India. In Germany it is 0.82 million kilocalories. For vehicles, that we can see in the slide, the bikes and the four-wheelers, so lighter material that should be used for the cars. Instead of steel, we should use aluminium, fiberglass, plastics like this. So the lighter material, this will reduce the energy by 15%, and it can increase the economy by 6 to 8%. This is not a matter of joke. This 6 to 8% is not a small number. While the question comes of economy, 6 to 8% is a bigger form. Now for the refrigerators, the better technologies reduces the annual energy needed by a typical Danish 200-liter refrigerator with no freezers, and from 350 kilowatt per hour is needed. And also for light, 18-watt, we can see in the slide that we are having the tungsten bulb, which will consume the energy much more. So it is now replaced as LED bulb and like the 75-watt. So a 118-watt bulb can replace the 75-watt of LED lamp. So this is a serious issue. We should conserve our energy for the future needs. So these are the references I took all from this, and thank you for listening my lecture.